Greetings dear students. In this video we will discuss Gaussian integration formula. Our aim is to find definite integral, that is from a to b fx dx, and here we will approximate this function by the formula given by Gaussian integration, that is -1 to 1 gu du is equal to summation I from 1 to n wi gui. So this is the formula for Gaussian integration. Now as you see, we are given this function, but the formula is in terms of gu du, limits from -1 to 1. So that means first of all we have to transform this limit a to b into -1 to 1, which is the requirement for Gaussian integration. For this transformation we use substitution method and we put x is equal to pu plus q with conditions. At x is equal to a, u is -1, and at x is equal to b, u is equal to +1. When we put these values here, so it becomes a is equal to minus p plus q, and here we get b is equal to p plus q. So we name this as 1 and this as 2, and we solve 1 and 2 for values of p and q. So let me write it here. Solving 1 and 2 for p and p. So we get, after solving very easily we can find the solution. P will be b minus a upon 2 and q will be b plus a upon 2. And putting these values here, so transformation will be x is equal to b minus a upon 2 times u plus b plus a by 2. And then dx will look like b minus a upon 2 du. Now putting these two values in the given integration formula, so it becomes, let me write it here, so I, which is a to b fx dx, now will look like b minus a by 2 -1 to 1 f of b minus a by 2 times u plus b plus a by 2 du. And for simplification we will put this as gu. So it will look like, so it becomes b minus a upon 2 -1 to 1 gu du, where gu is f of b minus a by 2 times u plus b plus a by 2. So this is how we can transform the given integral into this form. Now formula for this is already known, where wi and ui are called weights and abscissa respectively. So we write formula here again, -1 to 1 gu du is approximated by I from 1 to n wi gui. So this integration formula is exact for polynomial of degree up to 2n minus 1. That means the formula minus 1 to 1 gu du will be approximated by w1 gu1 w2 gu2 plus so on wn gun. Now for numerical application, this formula is used for as a 1-point Gaussian formula, 2-point Gaussian formula and 3-point Gaussian formula. Let us derive this formula for 1-point Gaussian formula. That means we put n is equal to 1 here. And for n is equal to 1, formula becomes minus 1 to 1 gu du and it will be approximated by w1 gu1. So which is exact for polynomial of degree up to 2n minus 1. So here value is 1. So it is 1. So that means polynomial will look like up to 1 means u power 0 and u power 1. So let us solve this for the values of w1 and u1. Now first of all we solve left hand side and we first use first value, that is u power 0, that is 1. So minus 1 to 1 du, that is integration is u minus 1 to 1. So 1 plus 1, that is 2, and right hand side is w1 gu1, that is, so w1 is and gu1 is 1, that is w1. So from these two we get w1 is equal to 2. Now for second, that is u. Now let gu is equal to u. In that case, left hand side will look like minus 1 to 1 u du. So its integration is u square by 2, that is 1 by 2 minus 1 by 2, that is 0. And right hand side, that is w1 gu1, that is w1 into u1. So equating these two, we will get w1 u1 is equal to 0. So we already have w1 is equal to 2. Putting that value here, 2u1 is equal to 0 imply u1 is equal to 0. So we have value of u1 here. So that means putting these two values in the formula, so we get for n is equal to 1, minus 1 to 1 gu du will look like 2 g of 0. So which is the desired formula for n is equal to 1, which is also known as 1-point Gaussian Quadrature integration formula. Now let us derive 2-point Gaussian integration formula. Means for n is equal to 2. Then the formula will be approximated by w1 gu1 w2 du2. So we can easily derive that this will be a polynomial degree up to 2n minus 1. And what is n here? 2. 2 is 2, 2 minus 1. That is 3. So what are the polynomials which satisfy this? That is u power 0, u power 1, u power 2, u power 3. So again, we have 4 equations using these two. What are those? For first, u power 0, that is 1 here. So we already know that when we put 1 here, so it is minus 1 to 1, 1 du. So it is 2 equals w1 plus w2. So that is, let me write it again, w1 plus w2 is equal to 2. And for u, gu is equal to u. So it is minus 1 to 1 u du. So we already know this is u square by 2, that is 1 by 2 minus 1 by 2. It will come out to be 0. And here it is w1 u1 plus w2 u2. And the equation becomes w1 u1 w2 u2 is equal to 0. For u square, minus 1 to 1 u du. Here we have u square now. And integrating u cube by 3 minus 1 to 1. This is 1 by 3 plus 1 by 3. That is 2 by 3. And this is equal to w1 u1 square w2 u2 square. And equation becomes w1 u1 square w2 u2 square is equal to 2 by 3. And for the last, u cube minus 1 to 1 u cube du. And very easily, so this is u power 4 by 4, that is 1 by 4 minus 1 by 4, 0. And on the right hand side, w1 u1 cube w2 u2 cube. And the final equation becomes w1 u1 cube w2 u2 cube. It will be equal to 0. So we have 4 equations, number 1, number 2, number 3, number 4. So we have 4 unknowns and 4 equations. And let me write the answers here. So after solving 1, 2, 3, 4, so we get w1 is equal to w2 is equal to 1 and u1 is equal to minus 1 by root 3, u2 is equal to 1 by root 3. So that means for n is equal to 2, this 2-point Gaussian integration formula is g of minus 1 by root 3 plus g of 1 by root 3. Answer. Now for 3-point Gaussian integration formula, that is for n is equal to 3. And the equation will look like minus 1 to 1 gu du is equal to w1 gu1 w2 gu2 w3 gu3. So this is the equation, and very easily it will satisfy polynomial up to degree 2 is to 3 minus 1. 6 minus 1, that is 5. That is u power 0, u power 1, u power 2, u power 3, u power 4 and u power 5. So writing in the similar manner that we have done for n is equal to 2. So I am writing the final answer here. So it will look like gu du is equal to 5 by 9 g minus root 3 by 5 8 by 9 g of 0 5 by 9 3 by 5. So this is 3-point Gaussian integration formula. I hope you got an idea how we can derive these formulas. So now here we will see application of Gaussian integration formula, and the question is compute the integral of this by Gaussian formula with n is equal to 3. means we have to apply 3-point Gaussian integration formula. But before that, we know the form -1 to 1 gu du summation I from 1 to 3 wi gui. We have to transform given integration into this. For that, we use transformation formula, and here you see, here we have a is equal to 5 and b is equal to 12. So then using the transformation formula, that is 1 upon 2 b minus a times u plus 1 upon 2 b plus a. So when we put values, these values, so it will be 7u plus 17 by 2, and very easily dx is 7 by 2 d. So putting these values in the given integration formula, so limits will become -1 to 1 2 upon 7u plus 17 into 7 by 2 du. So 2 will cancel, and it is 7 -1 to 1 du upon 7u plus 17. Now using the Gaussian integration formula for n is equal to 3, so it is -1 to 1 gu du, it is summation I from 1 to 3 wi gui, and further this is 5 by 9 g of minus root 3 by 5, 8 by 9 g of 0, 5 by 9 3 by 5. And putting this formula here, so I will look like 7 into 5 by 9 1 upon 7 into minus root 3 by 5 plus 17 plus 8 by 9 1 upon 7 into 0 plus 17 plus 5 by 9 1 upon 7 into plus root 3 by 5 plus 17. And after simplification, this will be 0.87534, which is the desired answer here. Okay, let's have one more numerical. Using 2-point Gaussian quadrature formula, we have to evaluate this integral. And here you see we are already given integral with limits -1 to 1. So we directly use the formula, which will look like I from 1 to 2 wi gui, that is w1 gu1 w2 gu2, that is g of -1 by root 3 g of 1 by root 3. And putting this formula here, so it will look like 5 into -1 by root 3 cube 1 by root 3 square 2 into -1 by root 3 plus 1 plus 5 into 1 by root 3 cube 1 by root 3 square 2 into 1 by root 3 plus 1. So here you see, because we have cube, this will be minus, so this will cancel with this, and here also this is minus, this will cancel with this. So we are left with 3 by 3, that is 1 minus 1 plus 1, and here we have -1 plus 1, 0. Answer here. So I hope you got an idea how we can derive Gaussian integration formula and how we can make use those formulas for numericals.